Hello guys, welcome to this channel, welcome to Cosmic Essence, and my name is Maitray, and in this video we'll be looking at onto and into functions. So let's get started. Okay, so every function is either an onto or an into function, and if it is an onto function it cannot be an into function, and if it is an into function it cannot be an onto function. So both onto and into functions are mutually exclusive and an exhaustive pair of functions. Let's start with onto functions. Onto functions are those functions in which there are no free elements in the codomain. There are no free elements here in the codomain. Those functions are known as onto functions. So, how do we say which functions are onto? Now, if we know that there are no free elements in the codomain, then the first thing we know is that the range will be equal to codomain for an onto function. So this is one way to prove that it is an onto function. Another way to prove that a function is onto is that for all y belonging to the codomain, there exists some x belonging to the domain such that f of x is equal to y. If we can prove this statement, then it would mean that the function is onto. Let's see what it says. First, this is the symbol for all y belonging to the codomain. So for all elements in the codomain, this is the symbol for there exists. So for all elements in the codomain, if there exists some x in the domain such that it is the image of that element, then it would mean that there are no free elements in the codomain. So all elements here have some element here in the domain whose image it is. Okay, so let's see what into functions are. Into functions. Into functions are those functions which are not onto. That means there are free elements in the codomain in case of into function. So if there are some free elements here in the codomain, that would mean that this is an into function. So any function which is not onto is an into function. If I take some examples, first one, I am defining a function f from the set of R to R such that f of x is equal to x cube, where x and y belong to real numbers. Now let's look at this from the graph. The graph of x cube is like this. It extends on both the sides infinitely. So we know that all the elements or all the real numbers from minus infinity to plus infinity are an image of some element in the domain. So there are no free elements in the codomain, and the range is equal to the codomain, which is equal to the set of real numbers. So this is an onto function. Let's take one more example. If I take a function from set R to R such that f of x, y is equal to 2x minus 3, where x and y belong to R, see whether this function is onto or not. Now, if I make the graph of 2x minus 3, it will be a straight line passing through 0 comma minus 3 and 3 by 2 comma 0. So it will be a straight line like this, again extending infinitely on both sides. So the range will be all real numbers from minus infinity to plus infinity. So range is equal to R, which is equal to codomain. So yes, it is onto in nature. Another way we can see this is by saying whether there is a element in the domain for every element in the codomain. This is y, this is x. Now x can be written as y plus 3 upon 2, right? Now if y is an element in the codomain, does it have a pre-image in the domain for every element y? For every element y, there is always some element in the domain whose image y is available in the codomain. So yes, all elements here have a pre-image. That means there is some element here whose image is y. Therefore, this function is an onto function. If a function is not onto, then it is an into function, right? So these are the ways that we can see whether a function is onto or into. Right. So now the possible combinations of functions that we can get are 1, 1 and onto functions, 1, 1 and into functions, many 1 and onto functions, and many 1 and into functions. The most important one is the first one, which is also known as bijective functions, because only for 1, 1 and onto functions is an inverse defined. For only 1, 1 and onto functions is an inverse defined. For all of the others, the inverse is not defined. So let's take some examples for this. 1, 1 and onto, a few examples. Say function f of x, function from R to R such that f of x is equal to 2x minus 3. This is one example. Another one can be from R to R such that f of x is equal to x cube. Let's look at examples for this function. Function 1. I have defined a function f from positive real numbers to positive real numbers such that f of x is equal to x square minus 2. This function will be a 1, 1 and into function. Many 1 and onto. I am defining a function f from set R to R such that f of x is equal to x minus 1 into x minus 2 into x minus 3 such that x and y belong to R. This is an example of many 1 and onto function. Many 1 and into function, let us define a function f from set R to R such that f of x is equal to x square. This is an example of many 1 and into. Another example from set R to R such that f of x is equal to cos x. So these are the 4 types of functions that we get. Okay guys, so we looked at onto and into functions in this video. In conclusion, onto functions are those functions which have no free elements in the codomain, and the into functions are those functions which have free elements in the codomain. I hope you liked the video. If you did, hit the like button and subscribe to our channel, and tell as many of your friends as you can about our channel so that they can learn maths the correct way. So thank you.